Am I audible to all of you? Just write in the chat box. Okay. So I am sharing my today's presentation. Just a minute. So in the last class we have started the unit 3, which is sentence directed translation, and we already studied uh, the sentence directed translation. What does we mean with the semantic analysis? The semantic rules can be divided into two forms. One is syntax directed definition and the other is syntax directed translation scheme. Then we already studied the synthesized attributes and inherited attributes and the applications of syntax directed translation that we already studied. Then the syntax directed the definition, then the synthesized attributes and inherited attributes. Then we already studied the differences between the S attributed syntax directed translation and L attributed syntax directed translation. And we already studied the semantic actions, and we already discussed the question which is based on semantic actions, like the conversion of infix to postfix expression. This type of conversion you already studied in your data structure and algorithm, but in compiler design we can also done this conversion with the use of semantic analysis. So this numerical we already solved in the last class. Now in today's class we are going to take another numerical which is based um, on semantic analysis. So as you can see on your screen, that a question is given to you, and this question here it is for desk calculator. So on the left hand side, you can see two columns are there in the table. One is productions and other is semantic action. So on the left hand side, productions are there, and corresponding to those production, semantic actions are given. So the first sentence is S produces ES. So and its semantic action is print E dot well. Now the second production is E produces E plus E, then its semantic action is this. As you can see here, the left hand side E is different than the right hand side E. As you can see here, E produces E1 is a subscript. But, in order to differentiate it, the left hand side E is different than the right hand side E, and also this E, which is abbreviated as E to the power 2 is also different than the other e's. So these so in the question some productions are given, and corresponding to those productions semantic actions are given to you. So and the input is given to you 2 3 into 5 plus 4. This input is given to you. You can write this on your copy. This input 2 3 into 5 plus 4, and you need to also note this production. I produces I dash digit, and the semantic action performed is I dot well is equal to 10 into I1 dot well plus let's well, and the let's well comes with the this action is followed with this production. I produces digit, so I dot well is let's well. So you need to remember uh, these two semantic actions, and just remember that we have in the question the plus sign is there, the into sign is there. So in the input you have the into sign and the plus sign is there. So just write this input. Now we are going to calculate its value with the use of semantic action. Now we need to prepare a parse tree. So this is the solution. So as we are moving from the first, as we are moving from the first production, because we need to start with the first production. So the first production is s produces es. Now we need to move in order to calculate the string 2 3 into 5 plus 4. We need to proceed in a way that the parse tree will be like will follow the input string. So as the string contains the into sign and the plus sign, so we need to proceed it. So e produces e plus e. Then this e, from this e we can get the into sign. Then proceeding further, as you now this e into e, this is a production. Now from this e we need to move to I. From this I we need to move to I digit. And finally I will give you the digit. So our input is 2 3. So here we get the value 2. From here we get the value 3. And in the same way, here we get the value 5. So as we are moving, and our second last production is I produces 10 into I dash. So the 10 value, 10 into I dash. So the 10 value is into with this 2. So means 10 into 2 is been performed. So 10 into 2 is 20, and plus this 3. So 20 plus 3 is 23. So this value of E dot val is 23. And this as there is no operation performed, so this value is populated upward. So this 5 is populated upward, and this 5 is populated upward. So this e contains the value 5. Now as you can see here, we need to perform this operation, means into operation. So we need to multiply 23 into 5. So 23 into 5, this e dot val will contain, this e will contain the value 115. And we have the other value 4, and this is populated upward. And after as this e has value 4, and between the two e's we have the sign plus. So we need to add these two e's. So finally this e has got the value 115 plus 4. So finally we get the value 119 is our answer. So just remember how we are going to calculate or solve this question based on semantic actions. So all of you understand it. Just write in the chat box so that we can proceed further. Okay. So the final answer is 119. And such type of questions are very much or predominantly asked in your university examination. Of basically it can be 8 mark question or it can be 15 mark question, considering the 120 mark question paper. Now moving to the next topic. Now the next topic is dependency graph. So as the name suggests, uh, some nodes need to be dependent on the other nodes. So this is the definition of dependency graph: the interdependencies among the inherited and synthesized attributes at the nodes in a parse tree can be depicted by a directed graph called as a dependency graph. So basically this type of graph need to show the interdependencies between the inherited and the synthesized attributes. And the second point is this graph is directed graph. uh, the second point is dependency graph determines how attributes can be evaluated in a parse tree. So, for example, an edge from node A to node B means that the attributes of node A is required to compute the attributes of node B. Uh, Now we need to consider the production rule. A produces BC, and the semantic action is this. Now, how we are going to make the dependency graph? Now, as you can see on your screen, that AA is the parent, is a synthesized attribute, and synthesized attributes are going to be calculated only from their children. So is a synthesized attribute that depends on attributes B dot B and C dot C. So the dependency graph will have three nodes. These are the three nodes, as you can see on your screen: AA, BB, and CC. So dependency graph contains these three nodes with an edge from BB to AA. As you can see here, this is the edge from BB to AA, because in the case of synthesized attribute, the parent value can we can get the parent value from their children. So the direction of this graph is from BB, from the children to the parent. So as you can see here, from BB to AA, the direction, and from CC to AA, the other direction. As you can see here, this val here, the direction is from BB to AA, and here this well, the direction is from CC to AA. So the value of A is computed using the value at B and C. So that is how we are going to make the dependency graph. So moving to the next topic. Now, the next topic is intermediate code generator or intermediate code generation. So, as we already discussed, this is the fourth phase of our compiler design. So, in the analysis synthesis model of compiler, the front end translates a source program into an intermediate code representation from which the backend generates the target code. So, the benefits of using a machine independent intermediate code are these. So, first is retargeting is facilitated. As you can see here, retargeting is facilitated. You need to remember this word. This means that a compiler for a different machine can be created by attaching a backend for the new machine to an existing front end. So you can make other compilers by using the different language backend with the existing one. So by doing the intermediate code generation, we have this facility. The retargeting is facilitated. Then the second important benefit is a machine independent code optimizer can be applied to the intermediate representation. So the code optimizer is the fifth phase of the compiler, which is which we get from the output of the intermediate code generation. So these are some of the important benefits of intermediate code generation. So moving on, so the different forms of, I think I'm enlarging it. So now you can clearly see it. So the different forms of intermediate code are, these are the three different forms. First is the abstract syntax tree, which is abbreviated as AST in short form, and the second is the Polish notation, and the third is three address code. So both the above two, means abstract syntax tree and Polish notation, you already studied in the data structure and algorithm subject, and here we are going to study in much more detail the three address code, how we are going to form this three address code, and how we are going to store this three address code into memory. So the first is abstract syntax tree. So as you can see from this example, we are going to form the syntax abstract syntax tree of the expression A into B plus C. So this is the tree which is going to form from the abstract syntax tree. This is the normal expression tree B plus C and this is an into with A, and the abstract syntax tree in we are going to use the linked list. As you can see here, the BC is these are the two operators which and this is the operator plus operator, and B and C are the operands. And now here we are going into is the operator and its operand are A and the addition of B and C. So by using this method, we are going to represent the abstract syntax tree. So you can write this if a question is given to you that how many different forms of intermediate codes are there. So abstract syntax tree is the one method, then the Polish notation is the second, and the three address code are the third method. Now we are going to study the second type, which is the Polish notation. Now, as you can see on your screen that the postfix notation, also known as the suffix notation or the reverse Polish notation. So basically, its name is the reverse Polish notation. We are going to take the reverse Polish notation because a postfix expression has been calculated in the case of the compiler. So postfix notation is a linearized representation of syntax tree. So as an example, if we are given the inputs expression as x plus y, then in the postfix form we are doing as x y, and after that the operator is there x y plus. So if a production is given to you like this, E produces E1 operator E2, then its semantic rule is like E dot code is equal to E1 dot code separator E2 dot code, and lastly we are going to take the operator because we are converted it into the postfix form. In the same way, if a production is given to you, E produces a bracket of E1 and the close braces, then E dot code is E1 dot code. Here no braces can be written in the semantic rule. And in the third, E produces ID, then we can write E dot code is equal to ID. So by doing this, we and this, then the other example is Z is equal to A minus B into C minus D plus E plus F divided by G. So you need to convert this inputs expression into the postfix form. So just remember the precedence rule. So bracket is here it is written that bracket is having the highest precedence. Then the into and the divide sign is there. The operators are there. Then the plus and the minus sign. So you need to convert each according to the precedence. So first we are going to take the bracket. So we need to solve this a minus b bracket first. So it is converted into ab minus. Then we need to solve this C minus D. So it is converted into CD minus. Then we need to solve this F divide by G bracket. So it is FG divide. So this is the first step. Now we are continuing with this step, and finally we get the postfix form as this. So you already studied in your data structure and algorithm. You just need to practice it because sometimes they are given this conversion as well in the compiler design subject examination. So you need to just gone through some questions related to the postfix notation. Now the important topic which we are going to take here is the three address code, and it is much more used in the compiler design. Now, the three address code, it is a linearized representation of a syntax tree or a directed acyclic graph. Just remember this graph, directed acyclic graph. We are going to study this type of graph in Unit 5th in detail, in which explicit names corresponds to the interior nodes of the graph. So the term three address code is used as a statement, usually contains three addresses. So two for the operands and one for the result. So that's why it is called as the three address code. We are taking two addresses for the operands and one address for storing the result. So a three address code is an abstract form of intermediate code. So in a compiler, these statements can be implemented as records with fields for the operators and the operands. Record means rows and the fields means attributes in terms of data structure, or sorry, in terms of DBMS. So you need to remember it. So now we are going to just moving on. Now the types of three address code. So there are some, just a minute, some other students are waiting in the lobby. So I'm just allowing them. So there are certain three types of three address code and how we are going to represent it. So first, there is assignment statement. So if the statement is of type x is equal to y op z, here we have the operator. So for example, if we have a is equal to b plus c, here plus is a binary operator, and we can also have a is equal to b and c. So here we have the logical operator. Now the second type of three address code is assignment instruction, and it is of the form x is equal to op y, means x equal to operator y. So here operator is a unary operator. For example, if we have a is equal to minus b, or we can also have a is equal to negation of a. So this type of operator we can also deal with the three address code. So just remember, assignment statement we can deal with it, assignment instructions we can deal with it. Now moving to the next statement, the third statements are the copy statements. So the copy statement is of the form x equal to y. Then the fourth type is unconditional jump. And in case of unconditional jump, we are going to use the go to and the statement which here go to blank means here we are going to write the statement number or the statement name where we need to go. Like for example, go to m. So here we after this statement we need to proceed to the m statement. So the fifth statement is conditional jump. So here condition is given to you that if x reloc y go to l. So here reloc means the relational operator. So relational operator, as we already studied in the first unit, that relational operators are basically of type less than, then less than equal to, then greater than equal to, then not equal to. So these type of operators are relational operators. So conditional, in case of conditional jump, we have this type of statement. Now, other statements are also there. Now, the sixth statement is procedural call. So, here we have a special type of statements in three address code. We can also write as in param, P-A-R-A-M, param X, call P, return Y. So, this is the general form of the procedural statement. Param X means the X statement, then call P, and then return y statement. So here p is a function which it takes x as a parameter and returns y. So its use is it is used as a sequence of three address code. We can also write as param h1, param h2 to param hn and call the procedure and then return the y statement. So this can also be dealt with in a three address code. So the next type of statements are indexed assignments, and these are of the form x equal to y subscript or sorry y bracket I. So here the y is containing the array. We can also write these statements in other form, means x array equal to y. So these index type of assignments are also dealt with in a three address code. The last statements are of the form address and pointer assignments. So these assignments are also of this form. Address and pointer assignments are like this form. X equal to and y address assignment, and the pointer assignments are of x equal to pointer y and pointer x equal to y. So these statements are also dealt in a three address code. Now the important question is how to keep the three address code into memory. So we can do this by using three methods. So these are the three methods. So first is the quadruple, second is the triple, and the third is the indirect triple. So this is the most important question generally asked in your exams. So how we need to convert to keep the three address code into memory. Sometimes they are given you write the memory storage in the case of quadruple, or write the memory storage in the case of triples, and sometimes they are asking in all the three methods. So you need to remember all these three methods and how you need to proceed, how you need to store in the memory in these formats. So first we can take the quadruples in detail. So first is the quadruple. So a quadruple, there are some theory behind it, and after that we are going to solve a question and store the result in the quadruple structure. So a quadruple is a record structure with four fields, which we call as op, means operator. Then the second field is argument one, the third field is argument two, and the fourth field is result. So a quadruple consists of four fields, and these are its name: op, argument one, argument two, and result. The op field contains an internal code for the operator. Operators like param use neither argument to nor result. If you need to store the procedural call which you going to be calculate with the param statements, then these statements neither use argument to nor result. Then the fourth one is conditional and unconditional jumps put the target label in result. The contents of fields argument 1, argument 2, and results are normally pointers to the symbol table entries for the names represented by these fields. So you need to follow this while storing the result in the quadruples. So let us solve a numerical which is based on storage in quadruple. So a question is given to you. A, this is the question: A equal to B into minus C plus B into minus C. So this is the question given to you, and you need to store its value in the quadruple. So first, before storing it into the quadruple, first you need to make the three address code of this expression. So which is to be done with step by step method. So first, in order to to make the three address code, first, as you can see here, we are going to concentrate this part b into minus c. So first, here the minus c is the unary operator, so we need to store it in a temporary variable. Like the first statement is t1 equal to minus c. So the minus c value is going to store in a temporary variable t1. So now the second statement is uh, b into we are going to calculate this b into minus c. So now the second statement is b into t1, because we already store the value of minus c in t1. So b into t1 is equal, its value is stored in t2. Now we are going to calculate this value, this b into minus c, this. So as minus c is the unary operator, so t3 contains minus c. After that, we need to calculate is t4 is equal to b into t3. This we are going to calculate t4. And after this, we are going to as we are going to see, the plus sign is here, so we need to add this to temporary variable. So t5 contains the addition of t2 and t4, and after that the value of t5 is finally stored in a variable a, as according to the question a. So finally we need to store the value of t5 into the variable a. So these are the codes written in three address code. Now we can store these three address codes into the quadruple structure. So as quadruple structure consists of four records. First is the op record, second is the argument 1, third is the argument 2, and fourth is the result. So the first statement is t1 is equal to minus c. So operator is unary minus. You can write is u minus. Then the argument is c, and the result is t1. As there is no second argument is there, so it is left as blank. Now, in the second statement, you can also write the serial number here. The first is started with the 0, because we are considering the array array data structure. So as array starts with the 0 addressing with the, so first statement is right, we can write as it 0. Now the second statement is the first argument, as you can see here, is the first argument is b, then the operator is into, then the second argument is t1, and its result is stored in t2. In the same way, we are going to store the values of t3 and the t4, which are just the same as the 0 and 1 statement respectively. And now we are going to store the value of t5. So here the operator we are using is plus, then the first argument is t2, which is on the left hand side of the operator, then the second argument is t4, which is on the right hand side of the operator, and the result is stored in the t5. And the last statement is in the last statement, as we are copying the value, so we can use this operator equal to here. Now the first argument here is t5, and its value is stored in the a of in the a variable. So that's how we are going to store the value of the three address codes in the quadruples. So all of you understand it, how we are going to use the quadruple for storing the three address code. Just write in the chat box so that we can proceed further. Okay, so remember it that the quadruple consists of four records. Now moving on to the next topic. The next storage method is triples. So as its name suggests that the triple consists of 3 records and not the 4 as the quadruple contains. So to avoid entering, just a minute, to avoid entering temporary names into the symbol table, we might refer temporary values by the position of the statement that computes it. So just remember it. We are going to place the temporary names in the quadruple structure. So instead of storing the temporary names, we can also store the temporary values. So the three address code statements using triples can be represented by the records with only three fields. So first is the op field, second is the argument one field, and the third is the argument two field. So the fields argument one and argument two for the argument op are either pointers to the symbol table or pointers into the triple structure. So triple corresponds to the representation of a syntax tree or directed acyclic graph by an array of nodes. We can study the directed acyclic graph in the fifth unit in detail. So parameterized numbers represents pointers into triples. As we already discussed the parameterized numbers type in the previous topics, and the structure triple structure, whereas the symbol table pointers are represented by the names themselves. So these are some of the important points related to the triple structure. So now we are going to solve the same question as we already solved with the quadruples. So the same question is given to you, and now you are going to store this in the triple structure. So here in the triple structure we have only the three records. First is the op record, the second is the argument one, and the third is the argument two. So you need to first write the three address code of the expression given. So as we already evaluate the three address code, and it consists of six statement. So the triple structure of first statement contains the operator as unary minus, and in the argument one we have the c, and its value is stored in the just in the you can say in the first statement. Now the second statement is we have the operator into, and this the first operand which is on the left of into is b, and the right argument is the value stored in the zeroth statement. uh, so we can write this instead of temporaries. We can write this here in this in the bracket, like in the zeroth statement. So in the same way, we are going to evaluate the right hand side of the plus operators. Like we also have the unary minus here, and then we are going to calculate the b into unary minus c, and after that we are going to store the plus sign. So the plus sign will contain, the plus is the operator, it is stored in the operator, and its value here we can write the names, or we can write the positions where it is stored. So the first on the left hand side of plus, it is stored in the statement 1, we can write it here, and the second part which is on the right hand side of the plus operator, it is stored in the statement 3. So we can write in the argument 2 as the statement 3. And lastly, we need to assign this the value stored after the plus in the variable a. So lastly, we take it as the equal to sign, we take it as the operator. Then the argument one is taken here because we are going to store this the value in the argument one, and the argument 2 will contain the result we are going to store. So just remember how we are going to store the expression in the triple structure. So all of you understand it. Now here in the triple structure, instead of we are storing the temporary names, we are storing the values of the statement. Now, here a confusion is there why we are writing in the fifth statement A as in the first argument and not in the second argument. So here some explanation is given. The copy statement A is equal to T5 is enclosed in the triple representation by placing A in the argument 1 field and using the operator assign. So always remember that in the last statement of the triple structure, if we are storing or if we are storing the final value, then that final value is going to be stored in the argument 1 and not in the argument 2. So all of you understand it, how we are going to use the triple structure for storing the three address ports. So just write in the chat box so that we can proceed further. Okay. Now moving on. So you can also store the triple structure for the ternary operators. So the ternary operators like x indexed I equal to y requires two entries in the triple structures. So this can be stored in the triple structure as you can write the bracket equal to in the operator, then write the x which is on the left hand side and I on the right hand side, and after that you can use the in the second statement you can write the assign as the operator, because we are going to store the value of y in the xi, and then the zeroth statement what we are storing in the zeroth statement is going to be in the argument 1 and the y value in the argument 2. And in the same way we can also store the value of x equal to yi in this type of table. So just remember that in the first case we have x indexed I on the left hand side, and so only 5 minutes are remaining. We are going to finish this and the indirect triples. Uh, so just remember that in the first case we are going to store the x indexed on the left hand side by using this table, and in this case we have the indexed y indexed I on the right hand side. So some changes are there, we are going to store in this way. So some changes are there in the table, so you need to remember that. Now the last type is indirect triples. So this is the third way by which we are using the three address code into memory. So indirect triples, here we must know before forming the table what is the base of the table. So here we are listing pointers to triple. Just remember that we need to remember what is the base of the table. So here we are listing pointers to triples rather than listing the triple themselves. So we are not writing the triple themselves, but we are writing the pointers to triples here. That's why its name is indirect triples. So use an array statement to list pointers to triple in the desired order. So same question is given to you. So first you need to write the table as per your convenience. So you can write this is the base table, means its serial number 0 is can be pointed with the 14th statement. See, and the statement 1 is pointed to 15th statement. In the same way the statement 5 is pointed to by the 19th statement. So just you need to replace the triple storage with these pointer statements. So in place of 0 you need to write the 14th, in place of 1 you need to write 15, in the same way in place of 5 you need to write the 19th, and in the same way you can do the changes accordingly. So these. So this is the base table, and this is the actual table, or the working table is this. So in the case of indirect table, you need to form the two tables. One is the base table in which you need to write what the statement is pointing to. Here you can also take in the zeroth statement in place of 14. You can also write 114, or you can also write 100, but it is as per your convenience. But whatever you are taken in the base table, you need to follow it in the working table. So if you are taking the zeroth statement as the 100, then in place of this, or in place of this 14, you can write 100, and also here you can write the 100. So just remember, whatever you are taking in the base table, you need to carry on in the working table as well. So that's all with today's class, and we are going to discuss only one topic is remaining. Uh, a question is given. So today I am going to share this presentation on your email IDs, so that you can prepare it well. So that's all for today's class. You can leave it now. We are going to take the next class on probably on Sunday or Monday. So thank you very much.